Good day. Today I am going to give you an overview of what radioactivity is. By definition, radioactivity refers to the particles that are emitted from nuclei as a result of nuclear instability, and it happens spontaneously. It is one of the two reasons why isotopes are being formed, which will be discussed in a little while. So back to the radioactivity. This is done by an atomic nucleus that for some reason is unstable. It wants to give up some energy in order to shift to a more stable configuration. The process, also called radioactivity, emits energy in the form of ionizing radiation, which can include alpha particles, beta particles, and or gamma rays. Alpha particles are emitted when there is too much mass in the nucleus, making it emit 4 heavy particles, 2 protons and 2 neutrons. Despite their high energy though, alpha particles can only travel a limited distance as they always consume much energy due to their masses. Additionally, they don't have the ability to penetrate even the skin's outermost layer. Beta particles are emitted in 2 ways. Number 1, when there are too many neutrons in the nucleus, it will emit a negative beta particle, which changes one of the neutrons into a proton. Number 2, when there are too many protons in a nucleus, it will emit a positron or a positively charged electron, changing a proton into a neutron. Beta particles can travel farther than alpha particles and are also more penetrating, but can be stopped by a layer of clothing or a thin layer of a substance such as aluminum. Gamma rays, on the other hand, are emitted when there is too much energy, forcing the nucleus to emit such a ray, which discards great energy without changing any of the particles in the nucleus. Unlike alpha and beta particles, which have both energy and mass, gamma rays are pure energy similar to visible light. They have the most penetrating power among the 3 and can pass through barriers where alpha and beta particles cannot. As we have mentioned earlier, radioactivity is one of the 2 reasons why isotopes are formed. Isotopes are simply atoms with the same number of protons but a different number of neutrons and can either form artificially or spontaneously through the radioactive decay of a nucleus, that is, the emission of energy in the form of particles, as we discussed a while ago. An example of this is carbon with 3 known isotopes: carbon-12 with 6 protons and 6 neutrons, carbon-13 with 6 protons and 7 neutrons, and carbon-14 with 6 protons and 8 neutrons. These isotopes, however, could break down, which we know as radioactive decay. An element undergoing radioactive decay could become a different element. How does that happen? Take for example uranium-238 with 92 protons and 146 neutrons. When it undergoes alpha decay, or when it loses 4 particles, it could now become a new element, thorium-234 with 90 protons and 144 neutrons. Notice the change in numbers here. Now when thorium undergoes beta decay, it could become a new element, forming protactinium-234 with 91 protons and 143 neutrons. In this beta decay, there are too many neutrons, which is why it emitted a negative beta particle, which adds up to the number of protons. So from 90 protons in thorium-234, it became 91 protons in protactinium-234. We will not include the gamma rays anymore since we have mentioned that they do not change the particles in the nuclei when emitting energy. That is all for radioactivity. I hope you learned something from me. Have a good day.